Welcome back, everybody. I am Nathalie Niddam, your host. Today's conversation is all about regenerative skin health with a deep dive into exosomes and stem cells with a PhD in that department. We also talk about what it really takes to keep skin functioning just like it did when we were younger. I am joined by Debbi Barber, a repeat guest. It's been a couple of years since she's been on the podcast, but you're going to love her. And Dr. Jordan Plews, the infamous PhD stem cell and exosome guy that I referred to at the beginning. What we do is we break down the biology behind copper peptides, exosome signaling, and the role that stem cells play in skin repair and resilience. Now, if you happen to get the urge to try anything we discuss on the podcast today, you might just want to do that. You can go to vitaliskincare.com. That's VITALI skincare.com and use code NAT20 to save a whopping 20% off their amazing products. Now, this episode is brought to you by Nature's Marvel's natural bioregulators, Manukora honey, and Puri, the cleanest, bestest protein powder. And they actually have also other amazing supplements in their line, everything triple tested, all with special offers just for you. See the show notes below for details and enjoy the show. Welcome, everybody to the show. This is a very special episode. I have with me not one, but two guests. One guest is a repeat guest, Debbi Barber from Vitali Skincare. Debbi, I think it's been a couple of years since we've recorded together, right?
Right.
Founder and muse for the brand and self-made expert in this whole space. I mean, it is amazing your journey in this. And then also we have Dr. Jordan Plews, PhD, who I believe you guys work together and is helping with new product development, particularly a new product at Vitali. And so we're going to talk about skincare and copper peptides and all the things. I'm so excited. Welcome to you both to the show.
Thank you. It's so good to be back with you, Nat.
Yeah. So the good news is we have a girl voice and a boy voice. So everybody's going to be able to tell who's saying what when they say it. But my first question is going to Debbi. And Debbi, can you just share with us what was going on in your life when you first realized that skincare could actually become a career for you instead of just kind of like a little side hustle or interest?
I need to talk to my husband about that because it was a passion. It really was just a passion. And Dr. Faree is the one that introduced me to the copper peptide, the little foam that I use because I said, okay, you have all these amazing peptides. What have you got for crepey skin? And she said, oh, I can get you a prescription. I can get you, GHK-Cu and the foam.
Yeah.
And the story there is for the first time, this foam that was not exciting, but after 8 weeks, I thought there is something to this that is different than these $300 jars that I have from Neiman's and all. This is different. This is doing something. And so it really was Terry's the one that decided that, we need to share this with more people. And I think that we can develop this and we can save money because you're paying too much to the compound pharmacy. I mean, that was one of it because it was expensive.
It was all about cutting costs.
And so I have to give him, I don't know if it's the credit or the blame or what, but he's the one that really, pushed this into, we need to share this. And I thought this might last for a year and all my friends that play tennis and everybody, that's waiting at the door will get some copper peptides. And instead it just grew and grew and grew. And I mean, it's like we're now 5 years, Nat. I mean, this started from crepey skin, 5 years, and it's exciting. And now I cannot learn enough. My head hurts from studying. And I know Jordan, I wear him out with questions. And then after the calls, I send him more questions. And he's been so patient to teach. But it's exciting. Yeah. It's exciting to be almost 70 and having a whole new career that is totally separate and different from the career that 37 years I was in this marketing career and was not even that good in science.
And I just want to invite the audience right now to go to YouTube and take a look at Debbi, who's almost 70 years old. That's all I'm going to say. Just go to YouTube, find the podcast, go check out Debbi, who's in quotations, almost 70 years old. That's all I
Less
can
than
say.
a month.
Walking the walk, talking the talk, sister. You're doing something right. Was there a moment when you felt that this wasn't just about beauty anymore, but it was really about biology and longevity? Like
Totally.
because you're so passionate about it. And yes, we all want beautiful skin. We want to look great. We want to look how we feel. We want to reflect that vibrancy, especially as we're aging. But I think for you now, at some point, there's a flip that happened and moved into not just beauty, beyond beauty.
The biology, but health.
Yeah.
I think it was about the health. I got to the point where the healthier I am, the healthier my skin is, the better it's going to be, more beautiful. And so that's why I talk to people about the health. And even if they use it and immediately they don't find benefits like, oh, I've used this 10 days and I'm still whatever. I say, but you're improving. Yes, you're improving the health. Your skin is healthier just by applying this copper peptide and taking care of it and not putting junk on it, not putting the bad stuff. I mean, I feel as strongly about that. So yes, absolutely the biology. And the more I study and the more I hang out with people like Dr. Plews, I mean, the more I learn and then the more questions you have. And I just can't wait for the next product. Yeah. This one though, I'm the most excited about.
For sure. Well, I mean, look, the GHK copper as a peptide is just so freaking fascinating.
Right? It is.
It's this minuscule little 3 amino acid with a little copper thing attached to it that, what is it, 4,000 genes that it resets?
Yes, like it's up and down regulates.
And it's for skin and it's for brain and it's for the gut and it's for the nerves and it's like there's no end. And it is really high levels in serum when we're young, and it drops as we age. And so it's, and our ability to regenerate skin drops as we, like, it's just this amazing thing. So it's almost, to me, sometimes I think of it almost like, this is almost like a hormone replacement program.
Absolutely.
Right?
Absolutely.
Because you're restoring something to the body that allows the body to do the work that it was doing before.
Absolutely.
So,
absolutely.
Okay. So for Jordan, you haven't said a word yet. We've been taking up all the air.
Oh, just wait.
So what originally drew you towards regenerative medicine? Like, was it intellectual curiosity or some kind of personal health? Like, was it a personal health experience thing, or what took you there?
Yeah, I think, most people who get into science, they're hoping to make a positive impact on humanity. I did my undergrad in biochemical engineering, and then I worked for Pfizer in their bioprocess development group. Mm-hmm. And after about a year there, I felt like, we're doing a lot to cover up symptoms. I don't know that we're fixing problems. And I got Alzheimer's and diabetes in my family and things like that were cellular issues. And so that's what pushed me towards stem cell research. And that's what I got my doctorate work in. And it just really felt like that's the future here is how do we understand the regenerative system of the body and what can we do to boost it, help it, support it.
Love it. So when did you realize that regeneration could be applied beyond medicine and into longevity and skin biology?
It was really out of impatience. During my postdoc, I was doing a postdoc on regenerative medicine at Stanford, and I said, I want to apply this science in a practical way. And as you know, Stanford's surrounded with venture capitalists and people who want to invest. And I had people approach me for investment. And when I told them it's a 10 to 15 year runway, probably $50+ million to get something through the FDA, their response was more or less like, what can you do in 4 or 5 years, right? Mm-hmm. And I said nothing, right? But then they came back and said, there's some aesthetic products here that are cell derived. Can you do better than this? And I did some umming and ahhing over it, and I said, yeah. And so, it's been about 10 years now that I've been developing these cell derived topical products, but that's where it started.
Hey folks, I just wanted to throw a little message in here for those of you who are sending me all these incredible questions on social media or through YouTube or even on Spotify, wherever you're listening to the podcast. I wish I could get back to you, each one of you personally, but unfortunately I can't. And because I cannot, I created, about a couple of years ago now, I created a membership community where I get to hang out with people just like you. I do live weekly Q&As, almost weekly anyway. We also do have podcast guests come in to answer everybody's questions and do presentations. You get to interact live with those podcast guests. We will sometimes do challenges with some of the partners. Like in 2026, we have a mitochondrial enhancement challenge coming up where we're going to be testing mitochondrial function. We're going to be testing people's deuterium levels. If you haven't heard about deuterium, we've got podcasts coming down the pipes on that. And then people will be invited to follow a personalized protocol and then retest their mitochondria on the other side. We offer that in the membership community, and we do it at incredible discounts that you just can't find anywhere else. So if you're interested in hanging out with me and other like-minded people, which actually happen to include some pretty awesome practitioners and even some previous podcast guests who've come and joined the community, then I invite you to check it out on my website, natniddam.com/the-longevity-community, or just go to natniddam.com and look for the longevity community tab at the top of the page. Click on that and see if this is right for you. I would love to see you there. And we could make 2026 our best year ever together. So once again, that's natniddam.com. Just look for the longevity community tab at the top of the page. Now let's get back to the show. Vitali was built around clinical strength copper peptides, right? Mm-hmm. I mean, that's your kind of, to date, that's been your hero product.
Yes.
What was the moment you realized that there was still something missing, that there was another step? Because you have, until now, you had a beautiful line of products that's really effective, that gets really great results for people. I mean, I'll never forget some of those before and after pictures of people's burns and stuff that you had showed long, long time ago. When did you realize that you're like, we could take this another step further?
Yes. Well, it has to do a lot with aging and basically thinking about when we thought about the next product, we said, what can we do to make these products work better? That was one of the questions. What can we do to make these products work better? And then what can we do that can make it better even without these products? I mean, we wanted something. And one of the things in looking at aging and also stress, Jordan and I were talking about this earlier, there's this thing called stem cell exhaustion. Mm-hmm. And so no matter how wonderful if your peptide signal is strong and it's going, but if your stem cells are exhausted, they're not going to be able to read it.
Yeah.
And it's not going to perform the way it used to perform. And that's really, as I age, I'm thinking, how long is this going to work? I'm going to be 70. It carried me through the 60s. It's been wonderful. So really thinking about the stem cell exhaustion and how do we address that? What can we do with that? Yeah. And in the study, I realized that exosomes seemed to be the answer to that. That really seemed to be what would help the exhausted, tired, stressed stem cells be able to read the blueprint. Mm-hmm. And Jordan, happened to be a person who had researched this, and we were just so fortunate. I mean, this was meant to be because we were introduced to him at the right time. And I have to say, we could not have found a person who could have just worked with us, let me just say that, and patient with us about how much we needed to understand. But that is really it, is because this addresses the situation when you're aging and the wonderful products that are still doing, like if you're 40, probably the GHK is working wonderful, sending the signal, mm-hmm. Your stem cells are working, but at 70, when I read this about the exhausted stem cells, I thought, I get it.
I'm tired.
I'm tired. They are tired.
Well, I mean, you're adding another signal, right? And I think that's part of where, when you have something like a copper peptide that is so powerful, and you start to think about, okay, but let's look at aging tissue, and that's really what you're saying. Yes. The signal is really important, but are the worker bees there?
That is exactly. The factory workers need help. They're tired.
They need materials, and
exactly. Right. Yeah. That's exactly it. So that is why we were and we could have had 3 products by the time we had this product. But nothing. That is. I mean, this has been a long journey. Yeah. But it is pain. I mean, it is going to be.
And it's so interesting to me because I think what happens very often, people think, well, if some copper peptide is good, and we don't think it's doing enough, well, let's just use more. They might have said, let's increase the concentration of our serum. And maybe one of you wants to speak to this a little bit, but it seems to me that that's the equivalent of someone who's not speaking the same language as you and just talking to them more slowly and more loudly. Like their capacity to do what they need to do has been met. What they need is a different tool to help them to do their job, as opposed to just bringing more of them on board. I don't know who wants to take that. It's kind of a question, but.
No, I think, Jordan, I would say, though, that's about balance. I mean, this is about balance, and I know that because of that man sitting there. I've really understood that. But Jordan,
yeah, I mean, one of the ways I think about this, and kind of an analogy, is if you had your Thanksgiving dinner, right, and you finished your turkey, and someone walked in with 2 more turkeys, are you going to eat those turkeys, or are you going to say, like, I'm full, right? Most of us are full. But the next day, you're still going to be hungry, right? And I see a lot of focus on this kind of more is better mindset. Mm-hmm. And yeah, to an extent, you want to make sure you're getting an optimal amount. But beyond that, it's wasteful, and it's more about spreading it out over time. And I do think in a lot of areas of biology, more is not better, right? That's just not how biology works. Like you were talking about hormone replacement therapy earlier. If you went to a hormone replacement doc and they said, well, I'm going to give you 10 times the amount that guy down the street's giving you, you should be scared, right? Not excited.
Run away. 100%. I love that. So if copper peptides signal repair, what do exosomes signal that the peptides don't or cannot? Like we talked about it a tiny bit a minute ago, but maybe you could position for us, what's the copper peptide doing and what's the exosome doing that's filling the gap or completing the job or whatever the case may be?
Yeah, Jordan? I mean, we could speak to this for hours, so I'll try to keep it simplified here. There was a paper that was published about 6 months ago that I'm a co-author on, where we looked at all of the proteins that were being, produced by stem cells. These are peer-reviewed studies that are out there, and did a bit of a meta-analysis and looked at, particularly the main sources of mesenchymal stem cells that are used, like bone marrow, adipose, umbilical, right? And you can see the overlap in the amount of proteins. And basically what we found was that, yes, there's a good amount of overlap, about 2,100 genes that are all the same. But then if you look specifically at umbilical, which is often called zero age, they haven't aged yet, these stem cells have about 2,600 proteins that were not detected in the other forms of stem cells. So I think this is an ongoing area of study to really delineate exactly what is changing over time. But there are now also other studies out there that have shown that younger cells are producing a different array of proteins and biomolecules than older cells, which most people say, yeah, of course, that's common sense. A younger cell is different than an older cell. Right? In terms of what is actually happening there, we can dive into the different proteins, the growth factors, the cytokines, right? Interleukins. Generally speaking, when we looked at this from the angle of skin, we started putting them in different buckets. And what we found was there was an enrichment, particularly in these very early young stem cells, around extracellular matrix proteins. So that has a big deal to do with how quickly you heal, how well you heal, right? You can think about this as kind of the mortar between the bricks, where your cells are bricks. And the different cell types, if they don't have the right stuff to grab onto to move in when repair is needed, move into the wound or the damage, they just won't. And the cells that produce ECM naturally better, like fibroblasts, are going to outcompete them. And that's where you end up with a fibrotic scar with a lot of extra collagen, usually collagen 1. And it heals, but it's not quite as beautiful or as nice as it used to heal when you were younger, right? And so, again, we could dive in deep on any one of these things, but effectively the groups around immune cell activation, around extracellular matrix, around things like MMPs, which often dictate how well or how much you scar, these are all, higher, they're upregulated in these early umbilical stem cells and hence the exosomes that they're expressing.
Interesting. Well, it's interesting to me because I've used the Vitali serum to heal a surgical scar in the past, very small one on my chest. And, I used it with a bunch of other things, but I would imagine then from what you're saying that if I'd had access to exosomes at that time, that would have kind of I still have I was warned by every plastic surgeon who looked at this, you're going to have a scar, like a big scar. I have a hairline, very faint. You'd really have to, if you're that close to me, you're too close. But
you used it right after the procedure, right? I remember that? That's great.
But I wonder if I'd had the exosomes at the time, if that would have even enhanced the healing even more, right? Because from what you're speaking about, there's other signaling pathways that might have kicked in. So, okay, so let's talk about your partnership here. Let's talk about Debbi. Like you said, you don't chase trends, and I know you don't chase trends. Like you're like, but what specifically made you trust? And everybody's talking about exosomes right now. Mm-hmm. Everybody, they're the new kid on the block. They're not even that new, but so what made you trust Jordan in this hype-heavy exosome market? Because everybody's an expert.
No, looking at there's just so much hype out there. And as the more I study this, and Terry and I decided, yes, we definitely want zero age stem cells, exosomes. And so we said, we need a stem cell researcher. We don't need a cosmetic chemist.
Yeah.
So that was number one. We wanted a stem cell researcher, and Jordan had over 20 years, experience in this. And that was number one. But then second, he's a biochemical engineer.
Right.
So the beauty there is that not only can he do the research and deal with the stem cells in the lab, in the freezer, et cetera, but he knows how to take those signals and stabilize and put them in a bottle and actually put them on a shelf without being lyophilized. And he may talk about that.
Yeah.
And that was really important because, all of our products you can put on your shelf, and you don't have to send in a, ice chest or anything like that. So that biochemical engineer background just made him perfect for what we were looking for.
Love it. So Jordan, when you evaluated Vitali, what made you feel confident that this wasn't just some other cosmetic brand trying to greenwash, whitewash science and spin it into something that it's not?
Well, you just heard such flowery language from Debbi. I mean, it's hard to say no to someone who's as sweet and as nice. And at the same time, we share a lot of passions here, right? I think, we want to really make a difference and make products that work, make products that are going to help people, right? This is about improving skin health. The analogy I often use is I feel like so many products, it's like taking a tree with brown leaves and painting the leaves green. And the obvious thing to do is just water the tree, right? And so that's what we're hoping to do, is be more supportive to the natural processes here. And that's something we both shared. And they're great to work with, right? So consulting with them has been amazing.
Have you ever had to push back on formulation decisions because of scientific integrity?
Oh, yeah. All the time. I mean, so many people think that they know this area. I've yet to meet a person that doesn't feel like they can go and make a product themselves. And, most of those people...
We'll just throw this and this and this together. It'll be great.
Yeah.
It works in the kitchen.
Exactly. That's the same analogy I use. When you go to a formulator, they're going to treat your formulation like they're making a batch of cookies. They're going to throw it all in and mix it up. And for speed, they're going to turn the heat up because they want to get to the next run. And they're going to blend it as fast as they can. So I usually have to go in and be like, okay, don't do that. Don't do that. Don't do that. Let's do it in this order, right? And things that when you really understand it, it's common sense in a lot of cases, but you have to understand the business part of formulating products is speed and scale, right? Yeah. And so that's part of the expense with making a good product, though, is making sure they're doing it the right way at the right speed.
All right. So let's get into the science of source here. Like, we're going to talk about why zero age, umbilical, why you pick those. You mentioned it a little bit earlier, but what does the biological age of an exosome source matter more? Why does it matter more than consumers might realize? And there's so much, there's a lot of noise about this out there, and Lord
and
knows,
misunderstanding. A lot.
Oh my
of
God! You put 5
which,
different people with 5 different opinions, like professionals, in the
absolutely.
room. I don't know who's going to come out alive.
No, we understand that also. By the way, but
yeah. So tell us, Jordan. Like, why?
Yeah. So. I mean, this is something that in the last 5 years, I've spoken at a lot of conferences, nationally, internationally, on this. And I feel like the amount of misinformation has only increased. It's like you're saying, there's a lot more people standing up saying that they know what they're talking about here, most of whom have never set foot in a laboratory before. So, I'll start with the kind of common sense answer, which is that, if you, maybe when you were a child, you fell off your bike, you scraped your knee, right? It happens to all of us. Now, recall the last time you had a similar injury, right? You might remember that didn't heal so quickly and maybe not so scarlessly, right, as it did when you were young. So that's kind of where we are right now, is understanding that system is going back to those younger cells and borrowing their healing capacity, borrowing those instructions that are normally present there all the time. And, I started making products about 10 years ago with adipose-derived stem cells, and that was usually coming from liposuction aspirate, right? People, we were jokingly call this the Fight Club model. They're giving away the fat. At the end of the day, though, these are not the healthiest people typically, right? If you're getting liposuction done, you're not usually the youngest. You're not usually the healthiest. Yeah. You're inflamed. You got, environmental and age-related things associated, right? And if you really want to dig into the science, I point you back to that paper I mentioned before from about 6 months ago, where we're looking at this comparison. There's clear differences in what you're producing at a young age versus an old age, and they do tie to known healing and repair pathways. And they've even shown in a few studies that if you're to take the exosomes or secretome, the extracellular vesicles from an older cell and put them on a younger cell, you not only don't get a benefit, but in some cases it can be negative, because you're asking a young cell to run an old cell program effectively, when in reality you want your older cells to run the young cell program.
Either less than or equal to the age of your cells is what you're looking for in an exosome.
Exactly. Yeah.
Okay.
If you were to say, okay, I need a blood transfusion, and the doctor came in and said, here's the blood of somebody who's older than you and less healthy than you, or you can have the blood of someone who's younger than you and more healthy than you, I don't think you need to be a scientist to know what that choice should be. Right? Yeah.
Yeah, 100%. I would say that's a really good analogy. So what fundamentally differentiates umbilical derived exosomes from adult fat, PRP, or even plant cells? Because plant cells are all over the place right now. Like the marketing claims that these guys are making, like where does the umbilical cord population? And I mean, we're talking, and I maybe we should spend a second just reminding people that we're talking about exosomes, not stem cells here.
Thank you, Nat.
That's a massive distinction that I think, and I've had a few people on talking about this, but I think if someone's new to the podcast or they missed it, they went to get their snack last time while we were talking about it. I think it's really important to lay down that foundation of understanding of, we've mentioned it a little bit, but what is an exosome versus a stem cell? What's in this product? And then what really fundamentally derives these umbilical derived exosomes from adult fat, PRP, or plant stem cell marketing claims?
Sure. Well, so for me, I just think back to when I was doing my postdoc, I was in a heart lab, and effectively we were taking stem cells and injecting them into the hearts of pigs after they were caused a heart attack, an MI, and trying to fix the heart, because heart disease is the number one killer, and we want to fix that, right? And so I was part of a group that was working on that, and effectively whether they put different types of stem cells in from different mesenchymal sources, or took a stem cell and differentiated it into a beating cardiomyocyte, injected that in. In most cases, you did see improvement. But what really stood out to me was there were some groups where they were taking what was being released from the cells. At that time, we were calling it paracrine factors and things like that. It wasn't being called exosomes at the time, but that was put into a hydrogel, injected into the heart, and that was often as good or sometimes better, right? And the benefit there was you can't put a stem cell in a bottle on the shelf, right? Stem cells are growing in a very controlled lab environment. You have to control the microenvironment, incubators, et cetera, has to be done sterile or aseptic. So this is not practical. But the benefit here is that the exosomes are not alive. They are not cells. They're not dividing. They are just a packet of information. And that vesicle, that exosome vesicle, is protecting those, contents that are otherwise delicate. And so that can be put on the shelf and saved if done correctly, right? And that was the big aha moment for me. But, this whole shift is really, towards plant that you're talking about, to me reminds me of the history of human stem cell research, because the exosome stuff that we see today really was born out of human stem cell research. If you go back for a minute, you might remember George Bush banned a lot of stem cell research in 2001. That was overturned
really
in 2009.
Back.
Set a lot of people back.
Yeah.
But then you remember when that was overturned in 2009, 2010, we started to see this huge influx of stem cell derived products and people injecting stem cells. The FDA was not happy about a lot of this, but because of regulatory reasons and the brand value of stem cells, we saw plant stem cell emerge. And then all of a sudden there's a lot of plant stem cell products. So, the short and sweet answer here is that most of the plant or non-human cell derived things here are trying to benefit from the brand or the marketing of what was done with human cell derived products. You literally cannot sell a human cell derived or often a cell derived product in a lot of places around the world. So if you're a big brand and you want to sell something, you got to have another option. And I'm not going to say that plant exosomes are totally useless, but I don't think that they're really a comparator. It's like if I went in your front yard and broke a branch off your tree, you wouldn't go and run out to inject your blood into it to grow back the tree branch, right? But anytime, so we're kind of saying the same thing in reverse. Yeah. Let's take this plant-derived thing and expect regeneration in humans.
Yeah, no, that's really interesting. I mean, there's a supplement out there that are plant exosomes, but the promise is not to deliver information to cells necessarily. The promise is that is how the plant moves a lot of the phytonutrients and things that we want access to. And it delivers it at a cellular level because it's in an exosome, which I think is a really interesting concept. So it's not a plant exosome trying to instruct human cells to repair, but it's a plant exosome delivering nutrients at a cellular level, which I think is it's a nuance. Sure. But basically what we're saying is that it's not just that younger exosomes are more active. It's fundamentally that they're giving different, better, more youthful regenerative direction to the cell. It's reminding the cell, this is what you used to do when you were young. And the cell still hopefully has the capacity to do that. And if we look at Debbi's, I can't believe you're almost 70 face, clearly there's something to it. Going into to the umbilical cord, age 0 exosome, did that make the project more expensive or slow it down at all? Or why did you still commit to it?
Slow. Yes. I said we could have had 3 products.
Right. That's what you meant.
It was slow. It was slow, but you knew it's worth it. In fact, it's still, we're like 2 weeks away, I think, or like when this show's 2 weeks away. But yes, it's slower, but it's worth it. And because we learned every step of the way what was being done and why it's going to be better. Yeah. And so it's kind of like worth waiting for.
Yeah.
So definitely more expensive, more, it was going to be September than it's going to be October, but again, there's a reason. Mm-hmm. And Dr. Plews was not rushing anything. He was doing it right. I mean, the way we would want it to, the way Vitali would want our products to be.
Yeah. Yeah. No, but there's clearly a philosophical core alignment here between you guys and between all you guys. That is, that's how you build legacy, and products that actually work. Let's talk about some safety regulations and the insider truth here. And you've addressed some of this, Jordan, already. If a brand claims human exosomes, what is the single most important verification that consumers should demand? Let's help people to educate themselves a little bit here. So what should people be looking for?
We could do a whole podcast just on that, but I think, part
maybe
of this
the top
is
3 questions they need to ask and where to look for.
Sure. I think the thing that most people don't even think to ask is there any animal-derived products being used in the manufacturing, right? Is this, the most common thing if you're in a laboratory around the world growing a cell, a mammalian cell, is something called fetal bovine serum. It's very common. And if you've ever grown cells in a lab, you will have seen it. You've probably used it. The problem with it is that we have things like mad cow disease, which is a prion-based disease. And this is something that can't be filtered out. You can't, test for it. It's pretty much a risk that you take. And I know we've had outbreaks over the years, and there's places like New Zealand that have been isolated and their cows have been isolated. But generally speaking, feel it's a risk that's not worth taking by using that product. So not using any animal-derived products is an important one in my mind, not only for safety, but also batch-to-batch consistency, because if you're going and you're getting something from an animal cohort to feed your cells, that can be different every time, and that can have different effects. And we want a product that's very consistent. And the more you have changes, whether it's changes of donors, some people are they're getting the cell population, maybe it's from plasma from a different group of people every week, every month. This introduces variability that you just don't want. Yeah, that's
So
probably the
in
number
your
one.
case, are you basically sourcing very so help me out with this, because so basically people should ask, number one, are these human? Are these not bovine, or, is there how do you know there's no contamination? Is the lab basically also working with animal product? But also, from what you just said, how do you manage this whole sourcing issue about not wildly variable batches, or are you just testing every batch to make sure that each batch meets the criteria that you require? Because you can only get so many exosomes out of one umbilical cord. So.
Sure. Yeah, so we could delve in how you get consistency there. A lot of it is people imagine there's a new umbilical cord or a new source of cells every week, every month. That's not actually the best way to do it. Generally speaking, you're going to get multiple cords and put them into one master cell bank. You're going to test that cell bank to make sure that there's no communicable diseases in there. There's a standard list of those kinds of things to worry about. Usually we go a few steps beyond that, testing for things like Zika and whatnot as well. And then every batch, you got to do microbial testing, make sure there's no bacteria or fungus, and that happens multiple times through the process. The whole process needs to be done in a lab that's meeting cGMP standards, so aseptic technique, making sure things are basically as sterile as possible throughout. And then, like I said, the animal component I bring up because of the fact that it is significantly more expensive to feed the cells non-animal derived products. You have to use synthetic, chemically defined alternatives and things. That costs a lot more money, generally speaking. And so there's a reason companies don't want to do that, right? They're making better margin by using the animal products. But I would say that it's something from a safety and reproducibility standpoint, every company should be doing. But if you don't ask, they just won't mention it. Most people don't know to ask, frankly.
That's why we're having this part of the conversation, right? Because I think the consumer needs to know, where are the sticking points here? What are the places that people might be cutting corners, or whatever and so would that be a xeno-free sourcing? Is that what that term means? So guys, xeno is XENO. So you're really trying to stay away from the animal products just because of all of the things that Jordan just talked to us about. And I'm guessing that, when it comes to, are there risks in terms of contamination or immune reactions with poorly sourced exosomes? There's got to be. Again, you've just talked about this, like the sterility, and maybe you want to.
Yeah, I think a lot of what I hear out on social media is often a bit overblown. Like the scariest thing that could happen usually would require a company to do something malicious. And I don't think anyone out there is doing that, right? Yeah. Like, for example, if you were to go and to take a cell line that you knew was bad, like a cancer cell line, and you were trying to get exosomes out of that, that would be malicious. That would be crazy, right? I don't think anyone is in that bucket. But certainly there are places where sterility is maybe not up to code. They don't have great SOPs. They're trying to, when something gets really popular, as exosomes have been, you find people that are not experienced trying to jump on the bandwagon and benefit. And because they don't have that experience, they're going to cut corners, they're going to miss steps, they're maybe not following known practices. So this is where working with people who've really been doing this for years and have the proper background, usually PhD level, is important, in my opinion.
And the other thing is, I think that labeling standards are still not really quite up to snuff, right? So are there specific things you would direct consumers to look for on the label of the products they're using, so that, I feel like this part is a little bit just education for the audience. I mean, obviously this is going to be on all of your products, but what are the elements of labeling that you think are most important people need to look for, so that they can at least ensure that it's safe and that it's at least some efficacy?
Yeah, I mean, the short answer is the label is not going to tell you everything that you need to know, unfortunately. That's the truth. Like you should do a little bit more than read the label. When I'm looking at a label, though, I'm often looking at where are the preservatives? Because if you're making a topical, you need to have some preservative. If the preservative is right at the top of the list, that tells you there's a lot of preservative, right?
Yeah.
That's not a good sign. And usually it means that there's not a lot of active. And so the part that is related to the exosome portion, the active portion, that should be towards the top of the list. And then, there's basic things like we know if you go out in the sun, the sun's going to damage your DNA in your skin, right? It can cause a double strand break. Well, inside these exosomes, you got very, unstable molecules. So you don't want the bottle to be clear. You don't want it to be exposed to sunlight and UV, right? You don't want it to be oxidized. So using a double wall airless pump, that really keeps oxygen out. Should be pretty basic, but a lot of things out there are using a dropper bottle because it looks scientific. But every time you open that bottle, you're introducing air, you're introducing contaminants from the outside environment. So when you're talking about a product like this, it should be very well protected. Yeah. I do get a lot of people that are concerned about temperature. And
because we imagine it must be perishable.
Right. Yeah. And in many cases it would be, but you have to remember, what temperature is your body, right? 98.6 degrees, I hope. And that's more than room temperature. And these are floating around in your body right now. We found them in every biological fluid from lymphatic, blood, saliva, urine, right? So it's not temperature that is breaking them down. Often it's oxidation, it's other things from the environment, vigorous shaking. Even if you combine these too concentrated, the lipid envelopes bump into each other and they can merge. And there is some physics behind this. It's something called the Coiter's equation that talks about the physics of these vesicles. And basically, the larger the diameter of the vesicle, the more likely it is to pop. And so actually smaller is better. So, these are all things to consider when you're looking at a product. But again, you probably won't find all this on the label.
One of the things that as I've aged that I've started to understand, because, we're always talking about skin. Yeah, I got to take care of my skin. And then it comes to your awareness. A lot of the negative visuals that you're getting on your face, that you're seeing, is really happening under the skin. Like it's not just, having good skin is amazing, but all the stuff underneath is really what's holding the ship up, as it were. And so our exosomes, how deep do exosomes go in terms of their signaling effects? Like, is this all skin, or are we actually, and you mentioned the extracellular matrix earlier, like how much of that, like, can they really shift your skin aging trajectory over time? And what I am going to say to the audience is, if you're listening to this and you're under the age of 50 or 40, it's not too soon, because
that's right.
No, but because the younger you are, the earlier you slow things down.
That's right.
I didn't start taking care of my skin really till I was about 50. I was lucky that I had good skin until 50, but that was my kind of starting point, because it might take me back a little bit, but it ain't taking me back to 30. So anyway, talk to us a little bit about how deeply the benefits of the exosomes, and we could even bring in GHK a little bit here, because it may also play a synergistic role. But are we able to affect what's happening underneath?
Yeah, so there's some interesting things out there that have been studied. I think people's default is to say, it can't possibly be getting in. We have a great barrier. If you talk about it, again, as an engineer, I think about where are the places that this can get in? What are the sizes we're talking about, right? If you look at the typical diameter of an exosome, we're talking, 30 to 150 nanometers-ish. A lot of people talk about Daltons, and I've heard about people saying, anything bigger than 500 kilodalton. I've heard people say 20,000 kilodalton. I know a lot of this stems back to a doctor from 20 years ago. The reality is that the skin is not like a metal plate with holes drilled in it of a specific size. And I think that's how a lot of people think about it, right? We know that there's, right. Well, the skin around the eye is thinner. We know absorption there is better than, say, other parts, right? And there's a stretchiness and elasticity. We know we have sweat glands, we have hair follicles, right? just to kind of put it into perspective, if your typical cell is maybe 10 to 15 micron across, and your typical exosome is 30 to 150 nanometers across, roughly, if to fit an exosome down a sweat gland, typical hair follicle, it's like a marble down a well. We're talking about something thousands of times the diameter of an exosome. So this idea that you can't rub something on topically and get it down those wells is just not true. Now, in order for this to be effective, you do want to see the exosome making contact with a living cell. You don't want it all to be touching dead cells on the surface, of course, right? A lot of people think, okay, well, I'll just microneedle it in, that will work. And there is some evidence that that may help with the delivery, and there's other modalities that help as well. But you would be surprised by how much data from just topical application alone has led. And so the people ask what you've asked, how deep is it going down? And they imagine this little bubble traveling through this Byzantine maze through the cells, right? When I think in actual fact, what's more likely to be occurring here is that the exosome is talking to the cells near the surface, and those cells are changing based on the instructions that they're given. And then they, in turn, release their signals to their neighbors. And then you start a bit of a domino effect that goes deeper and deeper down. And then, of course, as your skin is turning over time, you keep doing this, you keep nudging in the right direction, you will see fresher, younger, better looking skin coming to the surface.
Okay. But it is still very much a skin intervention. It's not so much in the deeper layers of the dermis or down to the muscles, or like this is really, and I mean, look, great skin takes you a long way, but this is really addressing the health of the skin and the appearance of the skin just by renewing the cells as they turn over, so that you're ending up with younger, better looking cells.
Yeah, but I would say,
I guess. Sorry, let me rephrase that. Like, will it affect? Can it go deep enough to affect wrinkles at all?
For sure. Yeah.
Oh, yeah.
So this is the surprising thing, is that, there has been a few studies looking at histology where you can actually see an increase in collagen, an increase in elastin, an increase deep. Right, they're taking like a full skin punch biopsy and seeing all the way down an improvement. And so this is a growing area of research. But I think the thought is you can't possibly get down to the dermis. You can't possibly be doing anything more than the surface. Right. But that's not what the data shows. It is showing that, and it may take 12 weeks to get there, right? But at the same time, it is affecting all the way down the depth of a skin punch biopsy, at least.
Yeah, and we can't forget our friend GHK.
No, I was going to say,
right, because GHK-Cu, like, it's getting in there, and if I would think that the GHK, what a partnership. I mean,
that's what I used on my scar. I have a 6-inch scar from my spinal surgery, and once the doctor gave me of course, you can't talk to them about this, but can I put something? Just this lotion.
Nope, don't touch it. Gasoline.
But I used it and submitted my photos regularly, and was told that it was a month ahead of the healing of the wound, because I was using the exosomes and the GHK together and just covering my poor back, which was, I wouldn't even look at the pictures for the first week.
Jordan, would you say that an exosome skincare could be considered like a localized longevity intervention?
Yeah, for sure. I think of this much more as a treatment product, right? I think this is something that is supporting the health of your skin, and really just reminding your skin cells how to look and act young again.
Yeah, I love that. So if someone were to use this for years, I mean, we're at the beginning of the runway here. I mean, right. I'll be chasing Debbi and
that's right.
What cumulative biological benefit do you think we might see? I mean, we don't know necessarily, but.
I think over time, what you're seeing is your lifestyle, your genetics, aging, environmental exposure, they're infecting our epigenetics, right? And epigenetically, we're basically turning some genes off that used to be on. And the beauty here is that if you get that packet of information through an exosome, that gene that you normally were expressing is turned off, now it can still read that message in the exosome, and it can still get the benefit of that protein, that biomolecule that used to be naturally produced, right? And all these things are natural, right? At the end of the day, we think natural, we think plants, but natural to our cells is human proteins. On a human level, we all speak the same protein language, right? So over time, as that builds up, you're going to stay in a state that is more like when your cells were younger. That's what the science shows, right? And I think the more we can maintain that, the better. So in your analogy earlier, right, the speed at which things are going down is probably going to slow. Right. If the growth factors that you've turned off or aren't producing as much of, now you're going to have more of. And you've got the help of GHK copper in there too. So I think, is it a magic bullet? No. I think, nothing is. But I think that the big shift here is that I think we need to get away from what I would call the hero ingredient model, where we have one ingredient doing like 10, 20 different things and expecting the world from it, and instead need to embrace this idea that in order to change a lot of things, we need to have a lot of components. And what's in these exosomes, when you look at it from a protein level, we found thousands of different molecules, right? You're not going to have thousands of different things on your bathroom shelf. So this is a shortcut, right? To put back a lot.
I don't use them all.
But yeah, I think that's the other thing to mention here is like, when you mix together all these different products, sometimes they play well together, sometimes they don't. Part of the goal here was, how do we get as much into one as possible that's all going to be natural, healthy, and boosting the main things that your skin is going to be missing with time.
You've definitely are building synergistic products within your line. Like, you can't speak to anybody else's, but you are building synergy in your line. So where do you see exosomes fitting into that broader longevity stack? Like the things like peptides and the NAD boosters and the senolytics, like where does this fit into that whole kind of puzzle?
Yeah, well, see, I go back to the hallmarks of aging and think about, there's a lot of talk about mitochondria, a lot of talk about antioxidants, right? I think one of the big step forwards that we're understanding at this point is, even if you went and lived in a cave without any sunlight, you're still going to age. And so if you're not getting these oxidants from damage from the sun, where are they coming from? And now I think we understand it's coming from your mitochondria that are breaking down and they're releasing the reactive oxygen species. And we've been covering up those ROSs with antioxidants, when really we need to probably get rid of those cells or push them to recycle, right? Get rid of the zombie cells, the senescent cells. A lot of that is down to your immune system, and the stem cells have a role with the immune system. So we do know that some of what's in these exosomes is relating back to supporting and boosting immune function. And so I would expect that you're going to be quicker to get rid of those senescent cells on the surface. So while you're taking all these things internally, most people who care about that also want to look good externally. And so we're attacking it from both angles. I think that's a better, more well-rounded approach. Some might argue, if I take enough internally, eventually it's going to come out through my skin. But, for those who want to do everything, why not, go from both angles? Yeah.
My point of view on that, though, is also the body deals with things from a hierarchical perspective, purely based on survival, right? The body could not give a flying fajita how we look. Right? Like, it just doesn't care. You have a skin, it's got a barrier, it's doing its job. I don't care if it looks like a prune. I don't care what it looks like. It's there. We've got bigger fish to fry. And there will be bigger fish to fry as we age. So I do believe that, I think, the skincare, good skincare that's based on good science is going to deliver those nutrients to the skin where you need it, when you need it. Like, it's I think it's just foundational. We wouldn't survive otherwise, right? If there wasn't that hierarchy of needs that the body has dictated and sticks to there's no negotiating. So anyway, so let's talk a little bit about what people see. What's the first thing people notice? Like, is it texture, tone, inflammation, resilience? Healing speed, for sure. We've talked about that a ton, but let's talk about aesthetics a little bit, because we've kind of done the beneath the surface stuff. Like, what do people notice first, and how long does it take? I think that might be a Debbi question.
Well, initially, because I was fortunate enough to be using this for several months before the surgery and after. And during the surgery, my body, talking about exactly what you described, it was totally about building bone. I mean, I was fusing bone, and I was told that is my number one job. Anything I tried to do or talk about, your job is to build, do everything to support that. I had to stop supplements that were very good supplements because I needed the right kind of inflammation to build bone. So I learned so many things through this. But I did have my exosomes. I didn't have to get permission to put them on my face or, so I was sort of bathing in those. And I'm telling you, my body it was using so much energy to heal my spine. And yet my face and skin looks better and it's fuller.
Yeah.
That was what was so interesting. I thought, oh my goodness, my skin is thicker.
Yeah.
And one day I said, Jordan, does this stuff make your skin thicker? Because I'm feeling this. I'm feeling like my skin's like my daughter's skin.
So
and
how long
really
did that
exciting.
take before you started to notice, do you think?
About 8 weeks.
Okay. So, and that's what I'm wondering, right? So you're talking about texture, tone. What about things like beyond wrinkles, like barrier strength, redness, immune function? Like, can people expect to maybe see some of that? Like people that have those kinds of issues, and is it at a 2 month, 3 month, obviously everybody's going to be different and it depends on a million things, but how long do people, first of all, can they expect to see any improvement in barrier strength, redness, and immune?
Absolutely. And Jordan, you can talk more. You've seen the studies longer. I know Terry's has a red face all the time, and this has definitely toned down. I mean, we have seen this on Terry because he's Irish and he's got this red look a lot. And this has really made a difference. And so, Jordan, you can talk about longer studies. But
Well, what I would bring up is we put in a biomimetic of ceramides. So there's a blend of ceramides that is similar to the ceramides that your skin naturally produces to make its natural barrier.
Yeah.
And if you're scrubbing or you're using too many hydroxy acids and things, there's a variety of reasons you might have destroyed your barrier. Once you get to that place and bacteria and inflammation is getting in there, it's hard to get it out. And it's hard to get those cells to produce more ceramides again. So by putting ceramides in the serum, you almost having this biomimetic bio band-aid, if you will, to put that barrier on while the exosomes and the aloe and green tea and the things that are calm down that redness and inflammation and give your skin a chance to rebuild that barrier. Otherwise, people get caught in this cycle where it's just redness over and over again, it seems like.
How should expectations differ? And we talked about this a tiny bit. We touched on it between younger skin and older skin. Like, how do we, because, as we age, we want our skin to go back to being bounced right back. But so how do we manage people's expectations who might be starting a product like that, this in their 30s, their 40s, their 50s and beyond?
Yeah. I mean, from my point of view, if you're in your 20s and 30s, this is prejuvenation. You're probably not at a place yet where this is going to have a big move of the needle for you. This is probably more for, like, say, the 40 plus, but with some level of stem cell exhaustion, some level of obvious aging that they've seen on their face, right? I think in general, you should see fine lines and wrinkles go down. You should see redness improve. You should see some improvement in fullness. And a lot of that could be extracellular matrix, like collagen, elastin matrix underneath the skin, slowly strengthening and rebuilding properly, right? Those are the types of things. But the very first thing usually is tone and texture. And I have to remind people, your skin turns over not overnight. It takes, a good month or more for the skin to turn over. So you want to go through at least a couple of skin cycles. So when Debbi says 8 weeks, I'm thinking that's a couple of skin cycles. It's only going to get better after the third and the fourth, right? So give it at least a couple of months before you pass like a big judgment. But I will say most people do, within the first 4 weeks, see something that is visibly different and improved.
Even if it's just calming. Yeah, that's really good point. Thank you.
Or softening. I think soft. I mean, that was the other thing, both with GHK, with the copper peptides, is soft. There's just a softer
texture. Yeah.
Texture.
Well, I found, this is interesting. And I mean, to younger women listening to this weird thing happens as you age where the texture of your skin changes. It becomes a little rougher, especially below the mouth. And when you're using good product, you will notice that it will start to smooth out or
dry. It becomes
dry. Yeah,
you age, it's dry
for sure.
And you really need to do something about that early.
You need to do something. All right. So, what kind of feedback from customers impact you the most? What kind of just sets you back in your chair? What's the kind of feedback that just blows you away?
You mean like makes me excited?
Yeah. Well, I mean, I know the answer because you've sent me the pictures. I mean, there's healing. Look, there'd be the healing of the surgical wound on your back, number one.
No, that's number one. But no, people who have had problems all their life, and now this is, this is more with the copper peptides because we're just now releasing the exosomes. Yeah. But when we're solving a problem people who said, I always had bad skin in my young life, and now people are noticing my skin, and that it makes my day. Yeah, no, and then we had someone with a flesh-eating bacteria from Costa Rica, that she was in this clinical trial, and she heard about copper peptides, and she reached out to us, and I immediately sent her the 3% serum. And the picture she showed us, I mean, she'd been in this clinical trial, so her skin had calmed down, but she had all this scarring. And this was after just like 4 to 6 weeks. She said, I can tell a difference. The scar is starting to, and she had been dealing with this for a year. When she started applying the serum, she could tell a difference within 4 to 6 weeks. Wow. She said, and she just said, I cannot believe the difference.
Yeah. I just want to frame this to the audience, just so you guys hear. The flesh-eating disease had been basically treated. She was now left with the damage.
Yes.
And I think what's important about scars too, and I'm this is a different question also maybe, and I don't know if it's exosomes or GHK or both, but what about old scars? Like, can these products help with old scars? Because this is a fresh scar. The body is still going at it. So which is perfect time to go at it, clearly. And that's amazing. But what about older scars? Have you seen that it can be helpful? Do you need to irritate them a little bit to bring attention to it? Like, what are your thoughts on that?
In my experience, it is better to agitate the scar tissue a little bit. So whether you're doing a nanoneedling, a microneedling, something that draws the body to say, oh, this is still injured, we need to get back onto the healing cascade. Yeah. Otherwise it can, I have seen it improve without it, but it's much more slow.
Yeah. Well, it's interesting. I have a scar on my cheek. Actually, it's a birth scar. And it has, over the years, has improved. Just the last few years of using these types of products. And I've used the GHK-Cu for a long time. I'm pretty excited to see with exosomes, and maybe I'll give it a little poke every once in a while, but it's almost invisible now.
Wow. That is great.
Which, people used to come up to me all the time and say, oh, you have lipstick on your cheek. I'm like, no, I don't. All right. Have you ever seen a transformation that you're like, oh my God, this is like beyond cosmetic. This is next level? Because people are going to respond differently, right? Maybe based on their genetics, maybe based on their diet. Like, who knows? Like, have you ever seen a transformation that's just maybe made you go, oh, holy wow, this is crazy. I mean, now we're going to go back to GHK because we just don't have the track. We'll talk about this in a year or two about the exosomes.
Well, I have a lot of before and afters where I have seen skin, look significantly better. Like
it's on your website, right? Even some of
it's on the website, and I have people who write me and talk about, and they don't have to do this. They make a point to write and talk about how their skin feels. I love to touch my face again, or, things like that. And I call that a transformation. Yeah. And I had a scar. I was hit by a golf club when I was 9 years old and had a scar I know now that we could talk. And it was stories. A scar so you're talking now 60 years or 55 years. And I started putting the serum on, and I didn't microneedle or anything because it was a scar. And I put it on twice a day, and I put the oil on top of it, and it just faded. It truly did. Just amazing. It's barely there, but it's significantly flatter.
Yeah.
And I've had people actually, the person who does my hair, she came and said, I wish I could hold up my sweater and show you my breasts. And I'm like, what? And she said, I've been using the serum. And she had this procedure 10 years ago. And she had one place where the scar did not heal and one that did. And so she used the serum, and she used it as 4 or 5 weeks, not 5 minutes. And she said, it's totally flattened out like the other one. And she was so excited. So I have a lot of people with the scarring and GHK. That is probably, wound healing is where it just shines. Absolutely.
For sure.
Absolutely.
Okay. So let's talk about the more is better myth. We talked about it a little earlier. You can only eat so much turkey in one sitting, but many brands are like, oh, we've got billions, we've got trillions, we've got hundreds of trillions of exosomes. Why can higher numbers be biologically meaningless? Like, do we have any idea what the threshold or saturation point is on signaling molecules like this?
Yeah, I think the reality is that from cell type to cell type, it's very different, right? We got to remember it's not about the number of exosomes. It's about the cargo inside the exosomes, right? Mm-hmm. And so, if you have a bunch of boxes of junk, you don't want that. And in actual fact, if you spend a good time working in this field, you'll know that you can get more exosomes out of a cell by agitating it, treating it in a negative way, basically upsetting it and roughing up the cells. You can get more of these particles that can show up by an NTA analysis as exosomes, and they're not good. They're containing inflammatory markers, or they're not actually of benefit, right? Like, the secret sauce for me is, how are those cells being treated in the laboratory? It's kind of like the old physics adage, every action has an equal and opposite reaction. Well, you need to push the cell in the right way to produce the good stuff. If you're just trying to maximize for number of particles, number of exosomes, you're not likely to get the right blend. And so, I think from a marketing standpoint, this is what a lot of companies go with. But as I mentioned before, in biology, it's rarely a more is better. And this is why really we want to nudge the skin in the right direction each day. With a reasonable dose, with something that's more balanced, right?
What is in your mind? What's a reasonable dose? Because I haven't.
Yeah. If you're talking about hundreds or thousands of exosomes, you're probably too low. You should be in the millions or more. Okay. Now you start talking about billions, trillions, hundreds of trillions. It's getting pretty wacky out there. I know of one company that within the span of 5 years went from selling you 100 million to multiple trillions, and the pace at which they were moving forward, I really question that's true. Right. Mm-hmm. It's very easy to just keep adding a zero on to whatever you're saying. And, the proof is in the results, though. You were talking about results before. I've seen a lot of different exosome products over the years, and in many cases, a lot of skeptics. And the thing that really stood out to me was some would actually do like a split face and put it only on half the face for 8 weeks, and had many people come back going, okay, I have to stop, because I look like I have Bell's palsy here. I got half my face is like lower than the other.
That's
and
commitment.
When you have that, this is a great sales tactic if you can get people to commit to that. But most by 4 weeks or 8 weeks in, they see that difference in their own skin, and you can't deny that.
Yeah, you can't make me do that. It's not happening. I'm not losing 8 weeks on half my face. It's not going to happen. So would you compare exosomes to hormones? Powerful in the right dose, harmful or wasteful in excess, right? Look at the experiments that were done. I think it was a Japanese researcher on water, and speaking to water with kind words versus speaking to water with angry words. And it actually affected the physical structure of the water molecules.
Yeah, and I think it definitely, you need to think about what you're doing very carefully, and how you're treating the cells, and how you treat them does determine what they produce. What we're trying to do effectively is to trick these cells in the laboratory into producing the right blend. So they are reacting, thinking that damage has occurred, and producing a specific balance of exosome and exosome contents based on that. Whereas, others might starve the cells or subject them to different forms of damage that could result in a profile that's more inflammatory. I even was on another podcast a while back with a trainer for injections, and does a lot of facial treatments and lasers. And she found that, if you get exosomes from the wrong cell source, they can actually keep you in that inflamed period longer, not less. And so you're red longer, and it's actually not necessarily in your benefit, right? Yeah. So there are some examples of this, but I think it's about balance. I think the analogy here is more like, we understand if you had a set of multivitamins, right? You want a little bit of everything, so that if you have something that you're in deficit of, you've got it in there. It's not about taking 50,000 times the dose of one vitamin, right? It's not going to make up for something else that you're lacking.
Yeah, I love that. Perfect. Let's talk a little bit about what else is in there. Why pair exosomes with vitamin C, glutathione, and SOD, superoxide dismutase 2, specifically?
Yes, I'll talk real briefly about the vitamin C, because probably the number one question I've had in the last 5 years is, how do I use vitamin C with copper peptides?
Mm-hmm. And we want to keep them apart. Yeah.
Yes, we do. Well, we do if it's ascorbic acid,
Okay.
L-ascorbic acid, and that's what most people have been using. But I've learned, as you said, when the light bulb went off, I've studied and learned that there are other sources of vitamin C that actually are much more stable. Mm-hmm. They're oil-based, so they actually absorb deeper into the skin than the water-based. And we decided, okay, I'm going to solve this vitamin C problem for everyone, because we also have copper peptides in our exosomes, in our Vita product, not heavy amount, but we have a good amount to balance. Again, because if they're using the serum, they need to continue using that for the same purposes. But the vitamin C that we have added is stable, and it is in the product. So you do not need to buy another vitamin C when you use this product. You have two stable, THD ascorbic and MAP, which are two stable sources of vitamin C. And that was my first request. And I know that sounds funny, but he says, okay, we had the first formulation meeting. I want vitamin C that works with copper peptides. Can you do that? And, of course.
Yeah. Well, I mean, it's interesting with vitamin C, right? Because people think of it as an antioxidant and all the things, but vitamin C equals collagen. So
yes, absolutely.
It's crucial for collagen. So,
absolutely.
All right, Jordan, over to you.
Yeah.
Yes.
No, I was just going to say, that I think we all understand the importance of vitamin C. I think sometimes it's a little overblown, but certainly the low oxidizing forms of vitamin C are better, specifically when mixed with GHK. And you just generally don't want something like ascorbic acid that oxidizes very easily, floating around in there, doing damage to other ingredients and often turning brown. And, it causes a lot of effects around it. So coupling it with glutathione and it kind of extends the life of the vitamin C as well. It acts more like a time release, because in our cells, glutathione helps to recycle vitamin C and E through our cells. So that is a bit of a stabilizer and helps to elongate the value of this. So instead of this game of, I need really high percentage of ascorbic acid, you can actually use a lower amount of these low oxidizing forms and get a kind of a time release effect.
Great. And the SOD2? Superoxide.
Yeah, this is not something we're adding in as an external ingredient. This is actually something that stem cells are naturally producing. And we highlight it because in the body, that is the ultimate, antioxidant, really, right? I think there's a lot of attention given to vitamin C and glutathione, but when the cell needs to perform an antioxidant activity, that's its go-to. And so you're getting that as a side effect, as a natural benefit of the stem cell exosomes.
Okay. So if I understand it, the way these ingredients are working, they're like supporting actors, right? Yeah. We've got the signaling, we've got oxidative protection, we've got cellular energy. You're basically making sure that there's the right situation, right? Everybody's got what they need to kind of deliver on these instructions that are being delivered by the exosomes.
That's perfect.
Basically, right?
You said that perfectly.
Yeah. So.
And you don't have to buy 20 bottles. I mean, if you want to do that, you can, but this, that's one thing people like to simplify. Mm-hmm. Some people
it's doing a lot of work. Yeah.
There's a lot of work by the combining of these ingredients. You don't have to have as many ingredients. You don't have to have the separate C.
And the vitamin C. Did I ever tell you the story about having a vitamin C serum that was supposed to resurface my face that I spilled on a polished marble counter at a house I was staying at?
And it resurfaced.
It completely ruined the polishing of the marble, and
so it works.
And when they sent the guys in to fix it, the guy looked at me and said, "You put this on your face? Are you crazy?" I'm like, I don't know. I might be rethinking my strategy right about now. Are there any ingredients on the floor that you guys thought you really wanted to use that you're like, yeah, no, not going to work? Sounded good marketing wise, but just didn't. Like any hot ingredients that maybe you might have been, you might have said, well, we should have this. Everybody's got this in there, like salmon sperm, for example. I don't know.
Yeah, I mean, this is something that, I think there are things like that, again, a bit of a fad product right now. And I think there is some evidence to how it can help. I'm not convinced that the PDRN or salmon sperm is good topically. I think, right? And people will talk about the A2A salvage pathway for that, and there's ways to rationalize how it works. In my mind, it's more like you're taking DNA from a salmon and you're putting it in your face, and your immune system is going, this is not mine. And in the process of booting it out, it's probably cleaning up the area, and a lot of the benefit is probably there. So It wasn't something that made sense for us with this product, but certainly there is a lot of peptides. And when you start going through what's out there, the companies that sell the peptides are marketing to you, and you got to be careful. Some of the science there is really wishy-washy, and they can put together a beautiful one sheet saying what it does. So we did go through a lot that looked good on the surface, but then after digging in, it didn't have a lot of oomph behind it. But we did add some peptides that have been proven that, support collagen and elastin as well for that extra oomph. We've got things like, brightening agents like licorice root extract. There's a specific form of it that has been shown in a few studies to really do a lot more. So I think most people are looking for a brightening effect. So this is not a pure brightening product, but does, support that brightening effect as well. And you brought up longevity and NAD. So niacinamide really plugs right into that NAD pathway. It helps to draw blood flow to the surface, helps with absorption, great with blemishes and cellular energy. So, I wouldn't say this is everything that I would want to put into one single product, but if you were to go and buy all these and mix them together, chances are they won't emulsify. They're going to pill up, and, there is limits there.
Well, you talked about this earlier, right? I mean, the temptation to put it all in without paying enough attention to what are the pathways that we're stimulating here, what makes sense to do at the same time. There's something about timing of delivery, right? And of instructions. And I'm a big believer that if you give too many instructions all at once that are not that aren't all moving in the same direction, you could end up with either wasting or just like kind of confusion, right? So it sounds to me like what you've done is you've identified this stack of compounds that work together to get us to an objective. Is this the product that's going to be the one product that anybody ever uses ever again? No. Does it do a lot of heavy lifting? Absolutely. So, and I think that's reasonable. Like that actually makes sense. We should not expect. So, okay, a couple of more things. Do you think that skin aging can serve as an early signal of systemic aging? Like how deep do you think that relationship goes? Like the aging inside the body reflected in the skin? I might have something to say after you're done, but I'd like to hear your take on it, Jordan.
Yeah, I mean, the short version there is yes. This is something that often your nails, your skin, your hair are the first sign that something internally is not quite right. I think there's, we've all experienced something in the course of our life that showed up on our skin, and we're like, what the heck? And I think the better we get at connecting those dots, the better off we are. But I think there's still a lot of work to be done there. I can't tell you the number of times I just kind of overlook something and don't think anything of it. And then, later on, maybe that was because of this, right?
Mm-hmm. Yeah, I love that. Well, I mean, I've just gone through a bit of I'm not going to go into detail about it. I've gone through a really major health event over the last 4 weeks. And part of it was that my skin and my skin barrier got attacked. And I would say that in the last 2 weeks, my skin has aged from the inside. Without sun or anything. And there's no doubt in my mind, we're going to turn this ship around and make it better. But at the same time, it is remarkable to me how a systemic issue can show up in the skin. And it can do that fairly quickly. So it's, I'm just putting my 2 cents worth in here. I think, our skin is an expression. And I think it's part of how people with some of these chronic skin conditions like eczema or psoriasis, they get into so much trouble because there's so much energy being put on suppressing the symptoms and so little energy being brought to what's happening within the body to drive it. And, 100%. And I think this is where, the conventional medicine can poo-poo all they want skincare. But at the end of the day, if you're not going at it also from the inside, you're not addressing the problem. And that's this, we see things going chronic and really getting people into trouble. So
Nat, I have that. So, Dr. Free is our medical advisor, and she has been wonderful when people, because I answer so many people, the notes when they write what their situation is. And if I can answer it, and I've seen seen how it works. Yes, but there's so many, I shoot over to her and she will start, oh no, this is totally an internal situation that blah, 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 blah.
You said earlier, as your scar was healing and your job one was to heal bone, right?
Yes.
All that energy was going there. But what you were doing was topically bringing attention to the face at the same time.
Absolutely. And with love. It was,
I know. We know it. We know you. We know it. So how do you think, and maybe this is for Jordan, how might future topical therapies communicate with deeper tissue and immune systems? Have you ever kind of thought about them? I'm sure you've thought about it.
Yeah. Well, the skin is the largest organ, right? So
Mm-hmm.
I think it gets kind of relegated as this aesthetic thing, but it's our first line of defense for so many things. So, and it is, depending on how you look at it, the skin is a lot of different cell types. I think people think fibroblasts, keratinocytes, some people say 7 cells, but there's really more than 20 cell types depending on how you look at it. A lot of them are immune cell types, right? And so these immune cells are scavenging. They're looking for zombie or senescent cells. They're looking for invaders. You want your skin to be on guard. You want your body to be on guard, but sometimes it goes too far or not far enough.
Yeah.
And so again, this is where biology and balance is really the name of the game, and making sure that you don't have any bottlenecks in your biochemistry where something is missing and holding things back. I think, what's going to happen in the future is we're going to figure out ways to copy and paste the program of youthful immune activity and other things into the body. There is a well-known stem cell researcher that I'm familiar with named Dr. Hans Kierstead, who runs a company called Immunus, and they've basically in phase 2 right now with an immune secretome that is meant to do just that by the sounds of it. You're taking an injection of a secretome that's boosting the immune system. And so I think technologies like this, where we're thinking more broadly than the single molecule, are really going to change the way we age in the future. And they're exciting, right? And so there's multiple opportunities here to do that now.
I love that. All right. Last 3 questions, people. Where do you see exosome technology evolving in the next 5 to 10 years?
That's Mr. Jordan.
Again, I think we're moving towards a place where you're going to have maybe an exosome or secretome for the immune system, for the skin, for the brain, for the kidneys, for the heart, right? You start going in organ systems. I think what we start to realize is that each system has its own progenitor cells, its own conductors that dictate a variety of things in that area. And the more we can grab the whole set and apply it correctly, the more we can regenerate and boost what's there naturally. So I see maybe some narrowing happening where we're more specific and not narrowing down to say one molecule, but maybe instead of a whole soup that is different from company to company, we're going to circle around, okay, this is the optimum soup that we're trying to grab, and here's why.
Could personalized exosome therapies become possible? I'm sitting here thinking when a baby is born, we harvest their cord, we store it properly. What thoughts?
And Jordan did that.
Yeah. This is something, the umbilical thing, I think this is something that makes sense. But at the same time, if you look, a lot of my doctorate work was literally about molecular de-aging of cells. And so we're turning cells from an adult state back to an embryonic state. And from there, you can go forward, right? These are called iPS cells. And these cells can be turned into whatever you want and effectively be your own donor. Now, there's a lot of technical difficulties in that, but I think once that technology is more perfected, that's where we'll end up. And the other way to look at it is kind of the way that a lot of David Sinclair's work has been, where it's building on the same research and saying instead of the 4 factors that we know go all the way back, we'll take 3 and we'll de-age across the body. Now, the problem we have with that is how do you de-age everywhere? How do you get something everywhere, right? It's short of being a Gattaca baby where we put something into you at the embryonic stage, right? I think it's going to be tough for those of us that don't benefit from that. But I do see a future where some of that research is leveraged to literally de-age cells. And I think what we're doing in the meantime is copying and pasting from young cells onto our older cells to try to keep them in this younger state.
Behaving. I love that. Last two questions. What scientific breakthrough in regeneration excites you the most right now? And immunist sounds pretty darn exciting. Because if you can keep your immune system young, that's pretty powerful.
I think so. When I look at these technologies, like, Yamanaka won the Nobel for this, reprogramming work in 2012. And I think Exosomes got the Nobel in 2013. But it was basically this idea of using these compounds to literally de-age is very exciting. But if you really understand it, there is this possibility of, at least with the four factors, cancer, right? We know that.
Yeah.
I think it's a double-edged sword, right? When you look at the cells that are growing endlessly, naturally, that don't have a natural limit, those are embryonic stem cells, and there's cancer cells, right? So I think the future is around how do we get past that and control for that, prevent that. But the most exciting things in my mind are also arguably the most dangerous. Mm-hmm. The other thing that's really exciting that's more near term is a company called Mesoblast that got a stem cell treatment approved, I think, end of 2024 for graft versus host disease, if I remember correctly. And I think that was a big step to get any mesenchymal stem cell therapy FDA approved, big step. And I think we're only a few steps away from that being something, where we're maybe injecting exosomes instead of stem cells, because anytime you're injecting cells, it could have a capillary blocked up or something like that. Mm-hmm. Exosomes don't suffer from that problem. They're arguably inherently safer. So I think we're on that path where maybe that's the interim exciting technology that will come next.
Love it. Last question, and this is for Debbi. So you said the exosome is a standalone product if people want it to be, but let's say somebody is a Vitali user. What's the order of operations here? Is it exosomes first? Is it GHK serum first?
No, that's a very good question.
I just want to close it up like that because
no, absolutely. And we actually have that on the box, exosomes first and then the GHK.
And then moisturizer, eye cream.
And then the moisturizer and the eye cream and the body cream. Yes, absolutely.
And would you put the squalene, because you have the hydration boost, where do you put that?
I use it before every day. It's last, and I use it. I mean, you can.
So you use it almost like as your finisher.
Yes,
you talked about using it. It almost acts as a primer under your makeup.
Yes, right? It is under sunscreen or anything. But I use that every day, no matter what. I put that squalene because it's most like your own stems. It's like your own skin cells. It is amazing, and it's a simple product. It's a simple one ingredient, wonderful product that helps finish it off.
All right. Well, lady and gentlemen, it's been an absolute pleasure. Thank you both so much for your time. This has been deep education and inspirational. So, Debbi, thank you for your inspired work in this space. Jordan, thank you for joining forces with these people and bringing your inspired work into the space. Folks, if you want to get your hands on some Vitali product, which I would say could be a worthwhile endeavor, you'll want to go to vitaliskincare.com and you'll want to use code NAT20 to get 20% off. Thank you again, both. It's been
thank you.
Totally amazing time. Thanks so much.